Section 2.6, how to draw scatter plots and best fitting lines. Hey, a scatter plot's a graph of a set of data pairs, x and y's. If y tends to increase as x increases, then the data has a positive correlation. That means as the data points, all the points are scattered around, as they kind of rise, going up in the direction, it's considered to be a positive correlation. If the scatter plots, the dots sort of come down in this direction as we go across an x, that's a negative correlation. The points show no obvious pattern. The data have approximately no correlation. That's this picture here. I mean, I can't draw a line this way, that way, or anyway, I'm just spinning in circles. No correlation. All right, let's do some examples for you. Example 1, describe the correlation. Telephones, describe the correlation shown by each scatter plot. This shows the scatter plot cellular phone subscribers and cellular service regions. As subscribers go up, the service regions also go up. So the number, you can draw a line along here, they go in a positive direction. For the phone subscribers and the corded phone sales, of course, corded phones are going down these days, there aren't many left. These all come down in a negative direction. It's a negative correlation. As you get more subscribers, you have less corded phones. Now, how do we measure this correlation? A correlation coefficient is denoted by the letter R, is a number from -1 to 1 that measures how well a line fits a set of data points, or data pairs, x and y. If R is near a +1, the points lie close to a line that has positive slope. So if the value of R is 1, the points look like they're very close, they're almost on the line. Okay. If the R is near, this would be -1, the points lie close to a line that is negative slope. So on this end, you would have the points that are almost in line coming down in a negative direction. If the R is near 0, the points do not lie close to any line, and they are totally randomly scattered around. Again, you can't find a place to draw a line anyway. 0 is the coefficient. So you can assign a value of some numbers close to -1, like -1, -0.5, 0 for no correlation whatsoever, and numbers that become closer to 1 for higher positive correlations, 0.5, 0.75. All right, let's look at some examples of that. Next page. Next page says estimate the correlation coefficient. So it says tell whether the correlation coefficient for the data is closest to -1, -1/2, 0, 0.5, or 1. Well, let's skip this first one for now. Let's go to stuff that's a little easier. Look at letter B. If I'm trying to draw a line through that data, I'm really struggling to see if this goes in any direction whatsoever. I'm really thinking this is going to be close to 0. R equals 0. No correlation whatsoever. On letter C, I can definitely see a trend of going upwards. As we increase X, we increase Y. That is a very positive correlation. In fact, I'm going to say that's R equals 1. It's close to 1. It's probably a little less because it's not exactly on the line, but they're pretty close. Let's go back to letter A now. If anything, I'm going to say, these sort of come down in a negative direction. Not great. So I'd probably give this a negative. R equals a -0.5. A half. -0.5. That's at best. Those are pretty crappy points. Okay. All right. Now, where are we going from here? Best fitting lines. Okay, we all know our favorite equation in the world always says is y equals mx plus b. Well, we can get any line to have those properties, an intercept and a slope. We're going to take these scatter points, okay, well, even some of the bad ones, draw a line through it, and determine the equation of that line that goes through those points. Here are your steps. First is to draw a scatter plot of the data. So we'll give you some data, you plot the points, or the points already plotted, hopefully. Step 2, sketch a line that appears to follow the most closely the trend given by data points. There should be as many points above the line as below it. So, as an example, going to the picture above here, You could probably draw a line through that data roughly like this. Yeah, you could draw a line like this and still be, half the data would be one side or the other. But the data trends in this direction. It kind of goes that way. If you drew a line going this way, you could do it and cut the data points in half, but the trend would not be represented. This represents the trend of the points going up. Okay? And about half on each side. Now, the mathy part of this operation. Step 3, choose 2 points on the line. Now, I always suggest when you're picking points, pick points where the line crosses the 2 hash marks, like right here, and perhaps, right here. Because you get hard numbers, 4 and 75, and 6 and 125. You get good numbers. Don't pick the points they always give you, and don't pick some points where you have to kind of guess the value. Do the best you can to find points right on the grid lines. Makes your life easier. And the numbers are probably nicer to work with as well. So you choose those points, and these points do not have to be original points. So what do you have to do with 2 points? Well, you got to do your old favorite m equals y2 minus y1, x2 minus x1. Yeah, find slope. After you find slope, you now have the m. You have x and y's here, x and y, okay? With these 3, you can plug those 3 back into our old favorite y equals mx plus b. Find the b value by putting the y, m, and the x in. And then write your equation with the new b you found and the m you have here. Let's see an example. First problem, example 3, says approximate best fitting line, alternative fueled vehicles. The table shows the number y in thousands of alternative fueled vehicles in use in the United States X years after 1997. You guys weren't even around back then. Approximate the best fitting line for that data. Well, let's go through the steps which are listed above. First thing is draw the scatter plot of the data. All right, come over here and say, whoa, there's no numbers on here. How do I know where to graph them? Well, again, we want to scatter this data out pretty good. So we will start, the x is 0 through 7. So we'll start here at 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the y is the number of vehicles. The numbers start at 280. Well, we don't start at 0. We could probably start at 250. At the lower end here, 250. Let's see, we're going to 500. So if I do, let's see, 3, 350, 4, 450, 5. That's kind of tight. So I'm thinking we can probably do 50 per line here. So this is 250. This would be 350. This would be 450. And this would be 550. That's about as good as you can do. I always say try to get at least half up way each way of the graph. That's about halfway. That's all the way across. Well, through the magic of video and delay, I just drew the points. You could have paused it here to get your points drawn. And now draw a straight line through the best you can. If you have a ruler, that's great. They're always handy. If you do not have a ruler, you can use the edge of the paper, but I got a ruler here, so I'm going to go ahead and draw a line. Now, I'm going to try to cross the grid lines where these numbers are so that I can get good numbers to work with. So as I lay this on here, remember, equal number of points on each side. And I'm going to live with that right there. I kind of like the way that looks. Yeah, I'm not great, obviously. But if I move a little bit further south, I might be okay. But I'm going to live with it. Now, you got it. Next step is to draw a line. Step 3 says you got to choose 2 points. Well, I like this one because it's right at 2 grid lines. And heck, look at this one, right on 2 grid lines. You can pick their points if you want, but these, any point along this line are better than their points because these are on the line. I'm picking actual points on the line, right where these grid lines meet. So I'm going to write these 2 points down. This first one is 10, 650. Right, I'm over 10. Oops, I'm sorry. I'm over 10, up 650. The other point is 7. Here's 7, and it's up to 550. Okay, let's find the slope. Pretty simple. Again, these are y's, these are the x's. So my slope equals 650 minus 550. 650 minus 50, and 10 minus 7. 10 minus 7. My slope then equals, I don't know, looks like 100 divided by 3. My slope is roughly 33. You're not going to be very exact with these numbers, okay, because you're estimating this. Okay, so now we have our m. I'm circling my m. Hey, look, I have an x and y already. So between x, y, and m, I can put them in our favorite equation again and get the equation by finding the b. So here I go. I'm going to use this x, this y, and this m. So the y equals 650 equals, it's mx. So here's my m, 33. My x is 10 plus b. Multiply that, so it's 650 equals what, 330 plus b. I subtract 330 from both sides. I get 320 equals b. And there's my b. Here's my m. Write the equation. You've done it. So y equals 33x plus 320. And, you know, visually check it out. The b is 320. Look at this line. It comes down to about, well, here's 250, 300, about 320. It works out pretty good. So you can at least go back and check your line visually to get an idea if you're right or wrong. All right, next page. Now you can use, oh, one thing I wouldn't tell you. Let's go back a second, sorry. From this problem, key information, when you're dealing with years. This is 1997. This is, again, 20 years ago, or no. So this 0 year is 1997. Well, 1 year later, it is, guess, 1998. But look at the x values. We're going 1 year from 97, 2 years from 97, 3 years. So these count all the way up. This is 99, 2000. 1, 2, 3, 4. This is 2004, 7 years out. So yeah, you graph the difference of the years, not the actual years. Okay. All right. Keep that in mind for our next example. Example 4. It says use a line of fit to make a prediction in the future. So use the equation of the line of fit from example 3, that's the one we just did with the cars and their alternative fuel, to predict the number of alternative fuel vehicles in use in the United States in 2010. All right, again, we're plugging our number into y equals 33x plus, what was it, 320? I forget. Yeah, the 320, I forgot. Well, we don't plug 2010 into the x. We go find out how many years from 1997 this is. Okay, so let's go back to our table where we've calculated that a little bit. Again, 0 is 1997, and 7 years out is 2004. We want to go to 2010. So okay, we left at 04, so here's 05, 06, 07, 08, 09, and 10. And how far away are they? Well, 04 is 7, so 5 is going to be 8 years away, 9 years away, 10 years away, 11, 12 years, 13 years. So 2010, you're 13 years out. That's the number we want to use. So back to this equation. They want to know in 2010 how many cars are around. Put the 13 in here for the x. So it's going to be y equals 33 times 13 plus 320. And yeah, I can't do this here. I don't have a calculator. So you multiply that, add 320, you get your number.